Going from a 3D file, whether it's a scan or a downloaded object, and getting it ready for 3D printing should be easy these days. But what nobody's telling you is actually how to do it and how to do it for free. So I run a small 3D printing business where I take a lot of scans and I design a lot of objects and I get it ready for 3D printing. And after I've made so many mistakes and I've taught myself with the right way to do things, I saved myself hours of work on every project. I'd like to share that with you. So in this tutorial, you're going to learn what I wish I knew when I started. As an ongoing tutorial, we're not only going to cover the basics of using Blender as a backbone for 3D printing, but we'll dive into the more advanced uses of Blender, like modifying existing designs and creating original products. From designing basic lab and office tools to complex designs like my prosthetic leg covers, all of this being through the Patreon page. You'll also get access to exclusive instructional content, design files, models, and assistance through our Discord. A big thank you to those who have joined the Patreon family. You'll get lifetime access to all this step-by-step content that'll be sure to make your modeling and 3D printing experience as successful as possible. Welcome to the video. Thank you everybody for joining us today on Patreon. Today we're going to be taking a 3D scan and converting it into a 3D printable model. For me, I do this for prosthetic work, but you could also do this for other things. Having a scan is nice because it is a direct reference to the physical world, and if you are copying a design, modifying one, or making one yourself, these days it is a powerful tool to have and is becoming more and more prevalent in the manufacturing world. I'm going to be taking a scan that I took of a silicone glove that I made for a prosthesis and creating a laminatable shell, which will be printed out of a PVA, which is a dissolvable plastic. I find it ideal for fingers and hands prostheses where I don't want to be chiseling out hard plaster. The reference that I took the scan from was this prototype I had made. We have made changes where I move the hook from the posterior side of the hand over to the anterior side. The hook is going to be used for typing and lifting of objects like bags and such for the patient's use. So to get started here, I've activated Screencast Keys, which is a plugin on Blender, so that you can see any of the buttons I'm hitting. Blender is an open source 3D modeling software. It is a multi-tool of video editing, as well as 3D modeling and designing. This is slightly different from your orthographic designing software, which are typically very expensive, and you'd have to pay for a subscription these days. Blender is unique by being open source, growing very rapidly, and extremely powerful when it comes to this sort of use. We're going to be using Blender version 4.5.2. I believe this is the latest version, but you can use newer versions as well. To download Blender, you'll be able to find the link in my link tree or in the description below. Like I said, it's completely for free, and we are going to be using some key add-ons, which we will download, and I will show you how to do that, but they are also completely for free. So hopefully you'll be getting a good source of knowledge from this video. So let's get started. When you download Blender, you'll see Suzanne pop up, which is a traditional 3D model of a monkey that's been with Blender for many years, but we don't need her right now. So we're going to right click and hit delete or X. To import any reference that you might have, you can go to File, Import, and select the format that you will be importing as. I will be importing some STLs as well as some photos, which I'll be working from for alignment purposes and sizing purposes. I've already copied them, so I'm just going to paste my objects, which are sized. And you can see here what we're working with. I've already created the shell which was 3D printed and I showed you in real life, as well as the hook appendage and the attachment points. Today though, we're going to be working from the silicone scan, which is this one found over here. This scan was taken a little while ago, but we have reverted back to its base scan, so I can take you step by step with how to make this into a 3D printable object. The first thing that I would like to show you is the add-ons. Blender, being open source, has many add-ons and they grow every day. Add-ons are coded in Python and they expand the functionality of the software, which is very unique compared to other softwares where the community is constantly adding more functionality to Blender as time goes on. So obviously, as more users use Blender, the greater its capabilities become over time. Let's review now the add-ons that I like to use. You can see them here on the right side of the viewport. If this little menu does not come up, hit the N button and they will unhide themselves. Now, if you're using a fresh instance of Blender that's been downloaded, you may not have these, in which case we're going to go ahead and add them. Click on Edit and go down to Preferences and go to Add-ons. In the Add-on tab, you can search for your favorite add-ons. You can see I have them already ticked off, but here are a bunch of my favorite add-ons. In future videos, we'll go into depth about them. The one that I think is the most important for this operation is going to be 3D Print Toolbox. So you'll be able to search, if you don't see it, 3D print, and you can see it filtering out everything else. Go ahead and click it. If you see on the right for install, then click the install, and that's it. The other add-on that's going to be very important is Bool Tools, which is how you add and subtract shapes to your model so that you can remove vertices or add vertices, add shapes, remove shapes that you might need for 3D printing. So go ahead and also search for Bool and it should filter out and enable it. If you do not see them under add-ons, go to Get Extensions. Get Extensions needs to be connected to the internet. So if you click on Get Extensions and you don't see anything, you might see an option for Add Internet Accessibility so that you can download these add-ons off of the internet. If you don't see them pop up immediately, you should go ahead and search again, Bool Tool and 3D Print Toolbox. These are the two most important add-ons that we'll be using today, but here is again a quick view of the other ones I like to have enabled. At the bottom, you'll see Measure It, which is a tool that you can use to measure your project, which also comes in handy. Go ahead and once you're done with that, go to the little hamburger icon at the bottom and make sure that autosave preferences is tabbed on, and if not, tab it on and click save preferences as well. Exit out of the preferences window and save. You can hit save by either doing Control S or going up to your files, save as, and save your project as whatever you like. I have it here saved as 3D printed core, which is going to be the purpose of this video. Make sure you save often, as Blender is a heavy program and it can sometimes crash just like any other. Blender does have an auto save functionality to it, where you can go to File, Recover Last Session, or from an autosave, and you can choose an autosave that you were working on before. They typically don't save very often though, so as I said before, please save often manually. Okay, let's get started on the meats and potatoes of this video. After you've imported your scan, we need to make it 3D printable. We'll make it 3D printable mainly by making this manifold. Manifold means to make an object waterproof or watertight, and that is essential for 3D printing. Blender has two major viewport options where you can see your objects. Right now we are in object mode, which you can see up here on the upper left hand corner, and you can hit tab or hit the down key and go into edit mode. In edit mode, you'll be able to see all the vertices that comprise your item. As you can see here, there are many vertices. I have to zoom in a lot just so you can start differentiating them. And as I zoom out, you can see they just become this blue mesh. Now this blue mesh is a preference for me. You may see it in a different color like orange. So don't worry if you don't see it as it is here, as the color doesn't matter. If you want to see how many vertices and edges and faces you're dealing with, go up to the Show Overlays icon in the upper right hand corner, drop down menu, and enable Statistics. In your statistics here, you can see that the total number of vertices is 631,005. You can see the number of edges and faces and triangles that comprise your item. There are a lot, and the more vertices you have, the more bogged down your computer is going to get. It also determines how much detail there is in your object. And detail is needed to a certain degree. You want enough detail to get all your anatomy and all the shapes right. I want to be able to see the zipper here properly. But also, we don't need so many that it's going to start slowing down our computer. So keep in mind, we have 631,005 vertices. We are going to decrease the number of vertices that we have. In object mode, we're going to go to modifiers. Modifiers are also scripts and add-ons where you can perform different functions that are native to Blender. In the modifiers search bar, you can go ahead and look for remesh, and remesh is going to do exactly what it sounds like. We are going to change the mesh from its base mesh that we got imported in to something that Blender understands a little bit better. Originally, when we import this mesh, it comes in as triangles. But when we click smooth, we're going to have a bunch of quads. Quads are shapes with 4 edges to them. And Blender understands this a little bit better, as is common for animation and other modeling. After you click smooth, we're going to increase the number of subdivisions right here. Right now we're at 4. We're going to increase all the way to 9. But as I go up, you can see that we are gaining more and more definition, and it's looking more like the original. Also note that as I increase the subdivisions, the number of vertices climbs rapidly. Here we're at 8 subdivisions, and you can see there is a slight bit of blockiness, and our vertices are now 76,000. As I said before, we're going to go up to 9 because that's where I feel the most comfortable when it comes to detail, and it looks basically exactly like the original scan. And now we're at 300,000 vertices, which is roughly half of what we were dealing with before. The other benefit to using this remesh modifier is that it seals your object. Before, we had an open hole here, which you can go back and view by clicking the real-time option on the modifier, and that will disable the modifier while not removing it entirely. So you can go back to see what you had before, and clicking the real-time button again, it'll enable it and show you what you're ending up with. To make this change permanent, click the down arrow on the modifier and hit apply. Now that we've applied the modifiers, we can start getting rid of some of these extra vertices. We have this plate that this hand was sitting on top of when I created the scan, and we don't need that at all. In fact, if you were to compare to the actual printed model I have of this lamination, I don't need a lot of this hand. By getting rid of what we don't need, we're going to decrease the amount of material that we'll need for the 3D print, which saves us money, especially if you're dealing with filaments that can be pricey. So to get rid of some of these vertices, we're going to use an add-on that we mentioned before, Boolean tools. There are other ways to get rid of extra vertices, like going into edit mode and enabling X-ray and simply selecting all the vertices we don't want and deleting them. The only problem with this is that we're back to having a hollow model, which in some cases is fine, but in some cases you don't exactly want to start backtracking again. It also leaves a rough edge, which is not ideal for 3D printing. So let's just go back and do this the easy way. Clicking on the back portion of the viewport, we're going to add a mesh and a cube. The cube gets added to the cursor, which is often located at the world origin. The cursor, though, can change if you are to shift and right click anywhere else in the viewport. If that happens to you and you don't know how to get the cursor back to the world origin of the viewport, just right click, snap cursor to world origin, and you're set to go. Now that we've added our cube, we need to size it up. We'll size it up or scale it up by hitting the S button. By tapping the S button and dragging our mouse, we can make it larger. And our goal is just to make it large enough to cover the extra vertices we don't need. Going into wireframe mode helps so you can see everything and make sure the block is covering the portions we don't want. Usually I'm covering about this much, but it doesn't really matter since we are going to be cutting up higher to eliminate a lot of the lamination that we don't need. I can reference my previous 3D print to make sure that we're not cutting off too much and that we have a little bit extra for the actual lamination. As you know, when you're working with composites, it's nice to have a little bit of extra room in case anything goes wrong. To execute the Boolean subtraction, I'm going to select the box and select the item that we're going to be subtracting from. Open up our menu and click Edit, Difference, And sometimes it takes a little while depending on how many vertices you're dealing with. But we'll go back into solid mode so you can see the cut that we just made. Now it's clear that the cut is much sharper than it was when you just selected a bunch of vertices and deleted them. This is more ideal for 3D printing, as when you're 3D printing, you're going to be 3D printing on a flat bed, and you don't really want any additional support that you're going to have to print at the bottom, because that's going to waste material and take longer. Now we're going to utilize the other add-on I mentioned, the 3D print add-on. Hopefully you can see it right above my camera. Click on it and you'll see the option for Make Manifold. I encourage you to click on this button anytime you do a Boolean subtraction, as sometimes there are hidden walls on the inside or vertices that are overlapping, which will be taken care of once you hit the Make Manifold button. So we're going to hit Make Manifold, and at the bottom you'll see an automatic modified section where it tells you what was changed. 0 vertices, 0 edges, 0 faces. So I was already manifold to begin with, but this is an excellent option for making sure that your models are watertight, which is essential for 3D printing. Now, depending on what you're doing, you're essentially done from here. Using this quick video, you could easily get a model to a 3D printable version very quickly with just a few free add-ons and your free Blender software. Now, in my industry, we like to place things on a pipe, and the pipe is used for lamination, as it makes working with the object slightly easier. Now, for me to insert a pipe into this mesh, I need to create a cylinder that's roughly the size of the pipe that I'm going to be using. When you add a cylinder, you can see it gives you options for how many vertices, and the radius, and the depth, which you can change right here before locking it in. The pipe that I use is roughly 20 millimeters in diameter, which means 10 millimeters in radius. And we're just going to give it 50 millimeter depth. Whenever you click on an object in object mode or edit mode, you can center it into your viewport by clicking the period button on your numpad. So when I hit period, it centers the object, and I'm able to pan around with the object being at the forefront of my view. I'm going to go ahead and hit G to drag my object over to my hand and rotate it by pressing the R button and rotating over the X axis by 90 degrees and hitting enter. I can look into the forward position by pressing 1 on my numpad and dragging my pipe to about the center of my hand. I'm going to do another Boolean modifier to remove the shape from my hand. This will give me a compartment where I could put a 20 millimeter pipe into and hold this arm in position while we laminate with our composites. Once again, I'm going to take our shape, hold shift and click the shape we're subtracting from, and go to edit and difference under Boolean. As you can see, it subtracted that shape from our hand with all the vertices, giving us a place to insert the pipe. Now, as I mentioned before, anytime we're doing a modifier like this, we're going to go ahead and once again in 3D print Make Manifold. It hasn't made any changes once again, but don't be afraid if it does. It's fine. Just keep clicking manifold over and over again until you get 0, 0, 0. If the shape of your item totally changes, I would start over, making sure you follow the instructions step by step to make sure that nothing changes dramatically. As always, you can ask me questions and I'd be happy to help. Now that we're ready for 3D printing, all that's left is to export our object. To export, make sure your item is selected. You can tell it's selected by having this orange outline to it. And then simply click export and you will see it pop up wherever you had saved it. Of course, you can change the format of the export by clicking format and selecting object, ply, or STL. From there, you can open the STL from your computer's drive and open it in whichever slicer you prefer. I'm not going to need to use any support since the hole isn't going to matter, and I'm simply just going to print this in a dissolvable plastic. This print shouldn't take very long and should be easy to work with, allowing me to laminate a composite over top of this shape and dissolve it out without having to chisel anything. You could also just laminate over top of a plastic with a PVA interface and melt the plastic out, keeping in mind you don't want to heat up your composite too much as it can degrade. For me, I'm going to be using my H2D printer, and I will sync my printer's information to the preview and change our filament to our PVA, which sort of looks like this. So hopefully with the help of this video, you were able to easily go from a simple 3D scan to a 3D printable model. We did this by taking the scan, making it manifold, removing some extra vertices, punching a few holes, and getting a side flat enough to print on. We did this completely for free by using Blender, a very versatile modeling software which you can use for all of your projects without having to pay any subscription whatsoever. We also utilized some free add-ons which are very powerful and made the job extremely simple. You can do this whole project in less than 5 minutes and have something printed and work on different projects while that finishes. Please let me know if you have any questions. Once again, I appreciate the support. We will have many more videos explaining more concepts on 3D printing and how to get things done efficiently by using free softwares and maybe occasionally paid ones if they are really worth it. I don't like spending money where I don't need to, especially when there are tools out there that are powerful enough to handle our needs and efficient enough to do it in a timely manner. Please let me know if there's anything you'd like to see modeled or described, and we'll make a video for that. I'll see you guys in the next one. We'll review how to make 3D printable shells so that you can make test sockets and exterior shells that go on your person or your patients. These skills are highly interchangeable and will help you on your Blender journey. Goodbye, and thank you for watching.